Hallo zusammen. Ihr habt sie wahrscheinlich alle gesehen.
Englisch?
Hörst du mich?
Ja, aber
Ja.
ich mache das später auf Englisch, das weißt du, ne?
Bitte?
Dass das auf Englisch haben wir gerade.
Ah, danke. Sorry, let's do it in English. Thanks for the note. Yeah. You may have seen the signs that say use more bandwidth. That means someone actually looks at the bandwidth. And Elisa has done it for the Amsterdam Internet Exchange and also here in the Congress Network. And Amsterdam Internet Exchange is the biggest IX in the world. And she will give you the insights on this. Please, an applause for her.
Wow. Okay, thank you. Yes, so I'm going to talk about S-flow and traffic analysis. I'm working for the Amsterdam Internet Exchange, and I was looking more at traffic statistics we cannot normally do with other tools that are out there. I also use the software now on the conference here, so in the end we're going to see some graphs from the traffic in this conference building from the last couple of days. And one thing up front, I would really like you guys to interrupt me if you have a question or want to ask something, because I do prefer to have that in between when the question is there and not at the end in a question and answer thing. So he knows, and he's going to run around with a microphone during this talk. Okay, so first I'm going to explain what this S-flow thing actually is. Then a little bit about the Amsterdam Internet Exchange, because the software I wrote to analyze the traffic there was kind of specific for this network and for the topology of this network there. So we might need to know a little bit about that. Then I'm going to explain something about the existing software which is out there and why we couldn't use that and why we, in the end, decided, because of performance issues, to write our own software to analyze the S-flow data. And there are some points about privacy. You might want to know what we actually do with all the data we get and how many of that we analyze. And of course, some pretty nice graphs in the end to see some results of all these things. Okay, so S-flow is a sampling mechanism implemented on switches and routers, which is sampling packets going over the network. You can sort of compare it to Cisco's iOS NetFlow, but not exactly, because NetFlow is flow-based, and S-flow, even if it's called S-flow, it's not really looking at flows, but it's only looking at packets. So you only get packets sampled you can analyze after that. So it is a statistical analysis. And that's why it is applicable to high-speed connections, and you cannot do NetFlow anymore on 1 gig ports or higher. So that's why we are using S-flow to do that. The S-flow datagrams collected on these devices are sent out via UDP to a central server, and on that server you have to have a collector software which is doing the whole analysis thing. The package format, how the S-flow datagram looks like when it's transferred to the collector, is defined in an RFC, and it's an open standard, so quite a lot of vendors implemented that on their hardware, like Foundry, Force 10, both of them we had here in the network as well, and some more. There's a list on the S-flow website who exactly implemented that and which devices. So I'm going to show you a little bit about the datagram format. I know it's really small and you probably cannot read that, but just to see what is actually in this datagram. So we have like normal packages, some sequence numbers and some versioning stuff, and we have an IP address where this package is actually coming from. So if you have a lot of devices, you know where it belongs to. And then in one datagram like that, you can have multiple samples. So these samples are up to 10 samples, I think, or the datagrams I've seen have up to 10 samples packed in one datagram. And these samples can be two different things, because even if it's sampled S-flow and everybody's explaining that like, oh, we have statistical analysis. It's not only statistical information. The statistical thing are the flow samples. The flow samples are really sampled from the packets. The other thing are the counter samples. I'm going to describe that a little bit more. So you define a sampling rate, how much packets you would like to see from the device, like 8K or 4K or 2K or whatever. And then you exactly get one out of this, and you can do your statistical stuff on that. It can provide the whole captured packet, depends of course on the packet size of the sample packet. It's limited up to 256 bytes, but if the packet is smaller, of course you also get payload information which is in that packet then. So that's the flow sample. What should I explain from that? So packet data, that's actually the important thing, because in the packet data here, that thing, you get the sampled header information, and that is not, it's not changed. It's exactly the same format like a TCP/IP packet. It's just packed inside this SFlow format. So to analyze this packet data in the end, you need different analyzes to decode usual IP headers and TCP headers or UDP headers or whatever. So it's exactly the same thing which is usually out there. And the counter samples are coming on time-based, so you can define a time frame how often you would like to have counter samples. And counter samples provide exactly the same stuff which is usually pulled from the switch for interface analysis now, octets, packets, errors from these interfaces. So the counter samples are not statistical at all, and you can do with SFlow the same graphing stuff MRTG is doing right now via SNMP. So that's what is inside the counter samples. Packets, octets, errors, broadcast, multicast, and all the usual stuff which is stored in the interface counters of a switch, for example. Okay, so that's basically the packet structure, what SFlow is, and to do something useful with SFlow, you need to have a device which is exporting SFlow data, and you need to have a server collector to do analysis on that. And that's, in the end, all you need to process this data somehow. Let's say something about the company where I actually implemented the software. So the Amsterdam Internet Exchange is a non-profit organization, like the name said, based in Amsterdam. And we have 4 co-locations where we connect members, customers to the switches located on each location. And we only operate on layer 2, so people put their routers behind our switches there. And we interconnect, in the end, these parties, and they can exchange their traffic over our platform. So we don't have anything to do with the peering agreements these guys have or all the layer 3 stuff they do. We only have the cables and the infrastructure, the switches, to interconnect them in these facilities. It looks a little bit like that. These are the 4 co-locations. We have 2 core switches, and around these core switches, we have multiple end user switches, to say so, connected. It's a redundant topology, so there's always only one core switch is working at one specific time. So you have either the blue lines or the red lines being active. And in the end, the people connected to these switches on the bottom or to these switches on top, there is a point where you have to sample the stuff, or where you have to sample the data to analyze it. What we do statistically right now is total traffic statistics from all the switches connected together. from the interface counters, MRTG stuff, pulled from the switches. That's basically it, no SFlow. And the thing is, by looking deeper at packets and not only at counters, you can do different stuff. You can analyze for different things. Like, for example, what I'm going to show later is analysis about how much IPv6 traffic that we have on this conference or at the AMSIX platform. And that's something you just cannot do with interface counters. So it is in the end for different purpose to analyze packets like that. The challenge to do that at the Amsterdam Internet Exchange was the amount of traffic. This is the current traffic graph from AMSIX. We do up to 220 gigabits per second in peaks, and you get quite a lot of data to process. So that was something I had to figure out when I started working on this project, how to do that and how it is even possible to calculate in numbers like that. And the first plan was to provide member-to-member information, because if you look only on the counters from each interface, you know how much traffic one person is doing on this port, but you still don't know where this traffic is actually going to, and people are interested in that. They don't know that, or they might know that by themselves if they do their analysis on their side, and we are only in the middle, so we do not really work with all the parties connected to the exchange. Yes?
Are actually the customers requesting this information from you?
Yes, they do.
Can you please ask a question again?
Okay, I was just answering or asking if the customers are really requesting this from AMSIX.
Especially small exchanges, they don't have enough resources to do analysis like that by themselves.
You mean smaller ISPs?
Smaller ISPs, exchanges, sorry, ISPs, okay. And smaller companies, they're just happy if we can provide information like that and if they see what's actually going on. Yeah, so they were requesting that. So yeah, the peering information for each member. It was the thing how you can do that on the Amsterdam Internet Exchange is that we have one or multiple ports per member, but we have a rule of only one router or one MAC address connected to each port. So you basically can filter by MAC addresses whose traffic this is what you actually see in that moment. So that was kind of helping out in determine where the traffic, to which member this traffic belongs on the way. Another thing we were sort of interested in the beginning is to see if we actually do some IPv6 traffic on the exchange or if there is some IPv6 traffic out there. So that was the second thing I implemented to analyze that. And yes, we needed a really efficient system to process that. So the existing software, which is available, a couple of them are listed here. Yeah, let me say something to each of them. So SFlow tool is not really an analysis tool. It's just a command line thing where you can receive the packets and you see output to standard out what's actually coming in there and what is in the SFlow samples. Of course, if you don't have a lot of traffic, you can put some scripts behind that and just parse it to somewhere, but that was not an option for our case. The other tools, PMACT and SFlow to MySQL, I've tested all of them in the beginning, so they all have this approach of we receive the data and we first save it to databases or whatever, and later on we can run analysis over these databases. But if you want to make a system more efficient than that, you could just do it the other way around and analyze it up front and then only save the data you already analyzed somewhere to a database or whatever. So that is pretty much the biggest difference in all the software which you can just download somewhere and the software I lately wrote at AMSIX. The commercial